Good morning, students. So in that previous video we already studied about force. So today we are going to continue that chapter. So now we are going to study about pressure. So what is a force? First we want to know the concept force. So that in that video I will clearly told it's just an action. It's just a push or a pull. So based upon that force, today we are going to study what is a pressure. So actually pressure is the intensity that we feel due to that force. Due to the external force, we are feeling the pressure. Okay. So what is pressure? Pressure, based upon the formula, we can write it is the area upon which the force is acting. So the pressure is the intensity at which the force acts. It's actually the intensity. That intensity, how the intensity? Intensity depends upon the area. If I am hitting this wall, then if I am hitting the wall which is like this, with the same force, I am hitting two surfaces which is flat and which is not flat. So at what time I will be feeling so much pain? That is when I am hitting the smooth surface or flat surface, I will not be feeling that much pain while comparing to when I am hitting a surface which is like this. Okay, why? Because the area is low, so the pressure is more. That is, pressure is force per area or force per unit area. If suppose the force is 100 Newton and area is 10 meter per second. So what is pressure? 100 by 10 equal to 10. 10 Pascal. 10 Pascal or 10 Newton per meter square. So, or if I am increasing the area up to 100, then 100 by 100 equal to 1. Okay. So pressure is force per unit area. Okay. So you can imagine if we are standing on a cushion. If we are standing on a cushion, and what happens? It will be going deeper. If we are standing on a bed, what happens? The bed will be going so much deeper. But if we are lying on the bed, it will not go that much deep. Why? Because the area when we are standing is low and all the weight, all the force is acting on that small area. So the pressure is more. But if we are lying means we are taking a large area, so the pressure will be less. Okay. So there are some applications of this pressure. First one is why the school bags have wider strap. So you know school bags is having wider strap to reduce the pressure. So we will not feeling that much pain. Okay. Then sharp knife cuts better. So why a sharp knife should be sharp? Because if you are cutting, it should be so much, the area should be so low so that it can easily cut, so that the pressure will be more, and we only need to apply small force, so the pressure will be more, so it will be going deep. Then tip of the needle is sharp. So if you are hammering a needle, the tip should be sharp, then only it will penetrate. If it is flat, just imagine if a flat needle we are hammering, then what happens? It will go inside? No, because it will be difficult. It will be going sometime, but we need to act. We need to apply so much force. Okay, so the tip of needle should be sharp. Okay, then depression of cushion, that I already told. So how much depression? It depends upon the force. That means pressure always depends upon two things. One is force and one is area. Or the pressure, we can define pressure as force per unit area, and it also depends only on two things, that is weight or force. The next one is area. Okay. Then this pressure is not only acting upon these solids. Based upon when we are taking the case of liquids or gas, even the liquids exert a pressure, or the gases also exert a pressure. Oh, just imagine if we are blowing a balloon. So here I am blowing a small amount of air is inside. So what happens? I am applying some force. That means I am taking my force. That means air I am taking and pushing and becoming into blowing. So what happens is some amount of pressure I am applying that increases the volume. Okay. So if I am applying more pressure, then it becomes weak. So what happens? There are so much gas molecules present in this balloon. So it will be exerting so much, there will be so much collisions inside this one. That means so much air particles I am blowing and closing this balloon, so it exerts a pressure. So this air particles exert a pressure. That's due to that pressure only it is like big in shape. Okay, if there is no pressure means it will not, it will be like always like that small balloon like this. Okay, so it is about the pressure of air. So in the case of liquid, I am speaking, just imagine it's a sea, or it's a water body, it's something, it's like a, just imagine it's water bottle or something. So at this point, if you are comparing at this point, the pressure will be low as compared to the downside. That means if the water is starting from here and is going downside, so in downside the pressure will be so much high compared to upside. Okay, so the water pressure or liquid pressure is like that. So it depends upon the depth. When the depth is or the height is increasing, the pressure will be more. At the same depth, the pressure will be same. The pressure will be uniform. Okay. Then next one is atmospheric pressure. So we know the earth is covered with a layer of atmosphere. So this atmosphere is also exerting pressure. Atmospheric pressure at the sea level is a maximum and it will be decreasing when it is going upside. Just listen. Atmospheric pressure at sea level, that is at ground level, is maximum. When it is going, the atmospheric pressure will be decreasing. You know, atmospheric pressure is so much high that it like it's the force of 10 elephants. It's that much power. So some examples I will show you. Some applications is there. Okay, so I am taking 1 glass of water. I am taking. This is just cardboard. This one. So I am keeping it close. Look, when I am keeping it close, and now why this paper is not falling downside, you know? Because it is now filled. There is no space between the particles. Now the atmospheric pressure is acting on this paper, and this atmosphere, due to this atmospheric pressure which is acting from downside to this paper, that's why the paper is not falling. Okay, otherwise it will fall. And there is many applications of this atmospheric pressure. You know, I told atmospheric pressure is so high. Then you can imagine why we are in the atmosphere. Why we don't feel that much pressure. You know why? Because our body is having blood pressure. Our body is having blood, which is having blood pressure, which is higher than this atmospheric pressure. That's why we cannot feel this atmospheric pressure. Okay. Then there are several applications of this atmospheric pressure. Then we are drinking with the help of straw. That is due to atmospheric pressure. That means we are sucking with a straw. So air is taking. So due to this atmospheric pressure only, the water is coming from downside. Then dropper. You have seen dropper for eye drops and all. Then syringes. Then rubber sucker. Rubber sucker, you know, the thing which is we are used to stick in the wall. That one. So these are applications of this pressure. So the pressure is an important topic. Just go through the topics in the text. Then if you are feeling any difficulty, you can ask me. Okay, you can ask in the comment section also. Thank you.